Welcome back to the channel, and today I'm going to try and solve one of the most talked about issues on all the Yaesu forums. Is it safe to use a DVI-d to HDMI converter lead on my transceiver, and will it blow up my radio? Stay tuned, I'll show you exactly what the problem is and tell you what Yaesu have been hiding all this time. It's got circuit diagrams and animated arrows and everything, it's brilliant. So let's go. Before we get started, I have to mention two people who've helped me massively put this video together. George, also known as Max Townend, and Hardy Whiteley Boocock, G4 SDX and G5 HWB respectively. Max and Hardy have given me so much of their time over the last few weeks to get to the bottom of this issue, replying to my constant questions, helping me make sense of complex circuit diagrams, and weeding out the facts from the fiction. So, if you've been living under a rock or taken a vow never to go onto any sort of social media, here's a bit of background. The Yaesu FTDX10, the FTDX101, and a little later the FT710 all came equipped with a DVI-d port, so you could connect an external monitor to make your shack look sexy, apparently. It seemed a little odd that they would use a legacy DVI-d port when most modern displays use HDMI, but it's generally agreed that they did this to avoid paying HDMI licensing costs and passing those costs on to the end user. This resulted in operators using DVI-d to HDMI converter cables to connect their external displays, and this was the catalyst that opened up a huge can of worms for Yaesu as reports began to emerge about display ports failing. First, let's see where the failures were occurring to help understand the why. This is a circuit diagram of an FTDX10, and here we can see an EP952 HDMI display processor. Yes, you did indeed hear that correctly, it's an HDMI processor. However, here you can see it's been configured to be connected to a DVI-d socket. Very cheeky, Yaesu. Also of interest is this 5-volt rail that supplies pin 14 of the DVI-d socket along with its series surface-mounted 630mA fuse. Repair reports all state that either this EP952 processor or more commonly the inline fuse are the point of failure. Anecdotal evidence also seems to suggest that these failures can either be instantaneous or happen over time. So that's why the failures occur, and before we get onto the actual reason for them, let's first debunk a few myths that have been circulating for quite a while, and at the top of that list is return voltage from the external display is passing back down the lead and blowing up the fuse in the radio. No. That would require the return voltage to pass back through pin 14 all the way up to the fuse. A quick look at the circuit diagram and we can see there's a big fat blocking diode in the way, essentially making this a one-way street. Second on the list is, you need a monodirectional cable. Bidirectional cables are the problem. Okay, so let's break this down. Not all HDMI cables are the same. Firstly, we have three generations, 1.4, 2.0 and then 2.1. The original HDMI 1.4 was a simple pin-to-pin bidirectional lead. HDMI 2.0 and 2.1 are more advanced with additional capacity for Ethernet and audio and a much higher bandwidth. 2.0 and 2.1 cables are considered to be active cables due to often having bidirectional components, and the ends of the leads are often marked source and sink or source and display. Some of these active cables even have separate power supplies for longer runs. But the important thing is that we're talking about a DVI-d to HDMI converter cable and not just HDMI cables. The converter cables follow the HDMI 1.4 pin connections, and the additional spare pins that were used in HDMI 2.0 and 2.1 are not connected to anything inside the transceiver. So I think we can categorically exclude this from our investigation. And finally we have theory number 3. Voltage drop across the cable caused by cheap Chinese hardware. Well, it sounds plausible if you say it fast enough, and there's a great article by Joseph D. Cornwall called The Ghost in the HDMI Machine. In this, he goes into a lot of detail about how longer cable runs, inferior manufacturing processes, and ever-increasing bandwidth demands are causing significant voltage drop across the connection. I've left a link to the article in the description if you do want to have a read yourself. Anyway, if we try and apply any of that to the DisplayPort failure, we do run into a bit of a problem. You see, voltage drop is not going to cause an increase in current, which will blow the 630mA fuse. In fact, it's quite the opposite. It's a fundamental principle of basic electronics. A voltage drop causes a current drop because they're directly proportional to each other, according to Ohm's law, which states that current, I, is equal to voltage, V, divided by resistance, R, meaning when voltage decreases, the current flowing through the circuit also decreases, assuming that the resistance remains constant. So again, I think we must discount this theory. Everything we know so far tells us that the overcurrent that blows the fuse or damages the display processor must be travelling in the correct direction from the 5-volt rail to pin 14 on the DVI-d connector. So let us discover what the actual problem is, and to do this we need to dive a little deeper and understand what happens when we connect two devices together, and also refer to the HDMI industry standards. Oh, and HDMI industry standards refer to source and sink. So the source in this case is the Yaesu transceiver, and the sink in this case is the external monitor that you are connecting. Oh, and also just to add a little bit of extra confusion, we're using a DVI-d to HDMI converter. So pin 14 of the DVI-d socket is actually pin 18 of the HDMI pin, and pin 16 of the DVI-d socket is actually pin 19 on the HDMI. It will make sense, trust me. Right then, with all that out of the way, let's have a look at what happens when we connect two HDMI devices. Firstly, the source, in this case the transceiver, sends 5 volts from the rail through pin 14 of the DVI-d connection, which then becomes pin 18 of the HDMI lead at the sink, which is the external display. Then 3.3 volts is returned back down pin 19, which is the hot pin detection or HPD, to the source, which becomes pin 16 at the DVI-d connection. This all initiates the extended display initiation data, or EDID. Essentially, this process wakes up the external display, keeps it awake, and the sink and source communicate information about things like resolution. There's two important things to note here. Number one, the source or transceiver is entirely responsible for the power for these processes. The sink connection doesn't contribute anything. And number two, according to the HDMI industry standards, this process will not exceed 55 milliamps. Well, 55 milliamps is nowhere near enough to blow a 650 milliamp fuse. In fact, the general rule of thumb is that a fuse will break in current that's around 3 times its rating. So what's actually going on? Something somewhere is allowing a substantial current surge to pass from the 5-volt rail to pin 14 of the DVI-d port, and we need to answer 2 questions to get to the bottom of this. The first question is, how is the transceiver able to supply such a large current? And question number 2, the second question, is what mechanism is causing the current to be pulled along the connection? Starting with the first question, the HDMI industry standard states short circuit current no more than 500 milliamps. In other words, the 5-volt supply from the transceiver should not be able to supply pin 14 of the DVI-d socket with more than 500 milliamps. It also goes on to state an ordinary 5-volt regulated supply cannot be used. The 5-volt rail must be protected whether it's connected to a source or a sink, and depending on whether the HDMI source is connected to a source or a sink, certain transient events can occur. And it's here where I think we find the first weak link in the chain. We need to ask ourselves what supplies the 5-volt rail that supplies pin 14 of the DVI-d connection, and we need to trace its path to discover what protections are in place. Working backwards, we can see that DVI-5V appears to be tapped off DSP-5V via a 0 ohm link. This DSP-5V supply can then further be traced back to the main board schematic, and by following connector P0090630 can be further traced to originate from an M04470AGL regulator, and it's labelled DV5. According to the datasheet, this regulator is capable of supplying a minimum of a 6 amp current before being limited. It is to be noted that some impedance will be encountered, such as track resistance, resistance of inductor windings and ferrite material, although this is likely to be a maximum of a few hundred milliohms. From what we can deduce then, this would allow a possible overcurrent to flow from DVI port pin 14, thus exceeding the 500 milliamp maximum short circuit current permitted by the HDMI standard. The diode should offer some protection against the complete short, but not anywhere near as much as needed. Looking at the datasheet for the fuse, FCC10631ABPA, we can view the pre-arcing time taken between a fault connection and operation of the fuse to be about 5 seconds at a maximum of 250% rated current, which in our case is 1.575 amps. In other words, or to put it more simply, to blow the fuse within 5 seconds, the current drawn must be around 1.5 amps. Another important consideration is that the current drawn Could well be lower than this for an extended period, and that would still cause the fuse to blow, but it would take longer to do so, lending itself to the theory that some of these are instantaneous failures and some are also over a period of time. Let's remember an HDMI source shall have 5 volts power signal over current protection of no more than 0.5 amps. And also a sink shall not draw more than 50 milliamps of current from the 5 volt power pin. So it is to be noted here that the FTDX10, although using a display processor that specifies it's for HDMI on the datasheet, it is not supplied with an HDMI port, nor is it pin-for-pin compatible. Yaesu have not designed this 5 volt power to meet the HDMI standard, as it will not meet the requirement for the 500 milliamp overcurrent protection with the 630 milliamp fuse installed. Any unexpected event that has the potential to draw 6 amps through that 5 volt rail will definitely cause damage. So to answer the second question, we need to be a little bit more speculative, I think. The HDMI standard refers to transient events, hence the need to limit the 5 volt supply to 500 milliamp. A transient event in electronics refers to a sudden temporary change in voltage or current within a circuit, lasting a very short duration, often caused by switching actions like powering on and off a device, and it can manifest itself as voltage spikes or current surges. Essentially, any rapid fluctuation in electrical conditions that quickly returns to a steady state. So a transient event in the sink could quite easily cause a massive current spike in the power from the source, despite the normal current across that lead being 55 milliamps. Max G4 SDX summarized this best by saying, 55 milliamps is what the current is most of the time, but now and again, for reasons best known to the Chinese, something in the monitor decides to boil a kettle. The fact is that these transient events happen all the time, whether we like it or not. It could be an electrostatic discharge, a lead being plugged in, rapid switching occurring in the sink device. It's always going to be difficult to pin it down to one particular cause without knowing the exact specification and circumstances of each case. What we do know, however, is that limiting the 5 volt supply current as stated in the HDMI standards to 500 milliamps would almost certainly mitigate any issues. One thing I can also say for certain is that the FTX10 does not meet the HDMI standards, and looking at the schematics was not meant to. The device has been designed with a DVI-d port in mind and should not be connected to an HDMI without significant care. Thanks for watching, and if you found this video useful, helpful or even entertaining, please give it a like and why not subscribe to the channel.